Hey everyone, Mr. O'Shea here. Today for geometry, we're going to be doing lesson 3.3, which is parallel lines, some more parallel lines, but more importantly, we're going to introduce triangle sum theorem. Main idea there being triangle and sum. You'll see what I mean in just a moment. So we can classify triangles using two different methods. One way is we're going to classify it talking about their angles, and the other way we're going to classify it talking about their sides. Now, in order to technically name them, we want to use both in the naming. So to name it by angles, our first one here is if we have three congruent angles, we're going to call that an equiangular. Oop, sorry, that's supposed to say equiangular. So it's a little test for you guys. Make sure you guys switch that to equiangular. The next one's going to be called a right triangle for the right angle. The third one, all angles are less than 90 degrees. So we're going to call that acute triangle, acute. The fourth one, you've got one angle that is greater than 90 degrees. Therefore, we're going to call that an obtuse triangle. So again, we've got equiangular. Sorry about that. That should say angular, not lateral. Equiangular, right triangle, acute triangle, and obtuse. And we can also classify them using their sides. If it's got three congruent sides, that's when we're actually going to call it an equilateral. And lateral just means side to side. Equa meaning equal. Some of you guys might have heard, if you play sports, like lateral movement, that means side to side movement. So equilateral is equal sides. Next one we've got two congruent sides, not all three. We're going to call that an isosceles triangle. And the last one, where we've got no congruent sides, none of the sides match up. So no congruent sides. We're going to call that a scalene triangle. All right, triangle sum theorem basically states that the angles of a triangle, so the inner angles of a triangle, have a sum of 180 degrees. Okay. Now there's a really great way to prove this, is actually if you take any size triangle and you rip the corners off. So if I rip the top kind of corner and the side corner and the other corner, and I put all of them together, but I laid their vertexes together. So that was one chunk of it. We'll call that chunk 1. And then I took chunk 2 and laid that with its vertex right at the next piece. And side 3, I'm sorry, angle 3, again with its vertex. No matter what size triangle you ever make, an acute, obtuse, right, doesn't matter, you're always going to find that all of the angles end up creating a straight line, which we know is 180 degrees. So just kind of a neat little way to prove that that's true. So we're going to use it now. Find the measure of angle 1. I know that all the angles have to add up to 180 degrees, so I can do 35 plus 65 plus angle 1 equals 180. It's going to leave me with 100 plus angle 1 equals 180. We'll subtract 100 here on both sides. And we're left with angle 1 equals 80 degrees. All off that idea that all the angles have to add up to 180. So in this problem we got a couple of different variables. We got x, y, and z. Now I see three distinct triangles in here. That one in purple, got another one here in red, where all of those angles have to add up to 180 degrees. You also have a bigger triangle around the whole shape, and all of those angles would have to add up to 180 degrees. It's got a lot going on there. We're going to use those properties and solve for those variables. So let's first solve for x. Angle x is in that triangle, so I know that those angles, 65 plus 39 plus x, has to add up to 180. We can do a quick calculation here. It's going to give us 104 plus x is 180, which means x equals 76 degrees. So that's our first one that we found. X is 76. Alright, I can use x to find y, because x and y are a linear pair. They're supplementary angles, they add up to 180. So I know that x plus y equals 180. And we know x was 76, so that plus y is 180, which means y equals 104 degrees. So now we've got x and y. Let's try to find z. So z is in this triangle on the right hand side. We know that all three of those angles also have to add up to 180, so we can say 21 plus y plus z is 180. And we know angle y was really 104 degrees. So combining our terms and subtracting, we're left with z equals 55 degrees. So we've got our angle x, angle y, and angle z. Alright, so now we're going to talk about exterior angles and remote interior angles. Exterior angles are any angle that's outside a polygon. A polygon just means a many-sided shape. So you've got an angle out here, an angle out here, and an angle out here. Those are all examples of exterior angles. It's basically if you extended the sides of a shape, which angles would they form? They also have these things called remote interior angles. And I'm only going to keep one of the exterior angles, and that's for a very specific reason. When we're talking about remote interior angles, you can only have one exterior to talk about those two. And the reason that that kind of is true is because if we have remote interior angles, we want the angles that are not adjacent to our exterior angle in question. So again, kind of a little bit more specific. They are the inside the polygon angles, that are not adjacent to the exterior angle. So we also have another theorem, triangle exterior angle theorem, and it states that an exterior angle, if we wanted to get the measurement of it, all you have to do is add up your two remote interior angles. So it's the sum of the two remote interior angles. So let's look at an example of that. I've got angle 1, the one in green here. And I've got two remote interior angles, that's our exterior one. Our two remote interior are the ones that are not adjacent but inside. And I know that angle 1 has to equal, well, if I just add up the two remote ones, so angle 1 equals 70 degrees. Angle 2. Well, this time around, the 113 is the exterior, and the other two angles are our remote interior. So we can say, well, 70 plus angle 2 equals 113. If I add my 2 remote interior, I get my exterior. So that means angle 2 equals 43 degrees. All right, let's kind of step it up a little bit here. Now we're going to incorporate parallel lines into the mix. So let's use what we've been covering for the past week with this. Anytime I have parallel lines, I'd like to extend them just so I can kind of get a better feel for what's going on. Now, you've got a couple of angles here. Hopefully you guys notice that it has that F shape. And F means corresponding angles. So if we're looking for angle A really corresponds with this angle right here. So that means that they're congruent. I can find that angle. We'll call it X. And I also know if that's X, then the angle above it has to be X as well from the markings. And 40 plus both those X's, because it's inside that triangle, has to add up to 180. Now I can solve this. Say 40 plus 2X is 180. And subtract 40 on both sides. And then divide each side by 2, and I'm left with X equals 70. Well, like we said, if that angle is 70 degrees, its corresponding angle is also 70 degrees. So A equals 70 degrees. Alright, please remember you guys can pause this at any time, rewind, go back. We are incorporating a few different ideas here, so feel free to do so. I've got a couple more parallel lines again, with some triangles being formed, and we want to know what is X. So to do this, the only problem is that we need to have the 3 angles of a triangle. If you only have 1, 2, you can't say that these two add up to 180. We have to know what this outside angle is. Or, this is X, we need to find these 2 angles to be able to do this. Well, if that's 90, I know the top one's 90 because those are vertical angles. But what are those? Well, if we think about parallel lines and transversals that cross them, we've got a big transversal here in purple. And this angle is an alternate interior angle to that one, so if that's X, that one is also X because they're congruent. Likewise, you have another transversal here in red. And the 2X is a remote interior angle to this top one, which means it's also 2X. So now it doesn't matter which triangle we use. Either way you look at it, it's going to be 90 plus X plus 2X equals 180. And we can solve this through. We'll get 90 plus 3X is 180. And subtract 90, so we're left with 3X equals 90. Divide by 3 and you are left with X equals 30. So we had to apply a couple of different things here, guys, parallel lines as well as triangle sum theorem to be able to calculate that. Alright, and our last one. Pretty tough one here. We're looking for X, Y, W, and Z. Can't really combine too much. Let's move this over a little bit. I can't use triangle sum theorem just yet because 30 plus W plus Z won't help us. But I do know that that angle has to be congruent with that one because of my parallel lines and my transversal, although it doesn't help yet. And I know W, angle W, and 2y minus 6 have to be congruent because they're alternate interior, although that doesn't help either. The angle 30 doesn't really give us too much either. Oh, but we can use the y's. We've got y and 2y minus 6. I know that those are same side interior angles, which means they add up to 180. So y plus 2y minus 6 has to equal 180, which means 3y minus 6 is 180. So I get 3y, I'll add 6 on both sides, 3y equals 186. I'll divide each side by 3, and we're left with 62, which means y equals 62. I'm going to go ahead and write that in there. Now the reason I write it in there is because now I can find w. W and y are a linear pair, which means they add up to 180. So w plus that angle 62 is 180, which means w is 138. Oh, I'm sorry, 118. My apologies. 118. Okay, so we're almost done now. We've got y and we've got w. Now we need to find x and z. Well, if you notice, we can find z. We can find z based on the fact that we've got a triangle and we know two of the angles. You can always find the third. They have to add up to 180, so we can say angle z plus 118 plus 30 equals 180. Some calculation will give us z plus 148 is 180. I'll subtract 148 on both sides, and we're left with z equals 32 degrees. So we've got w, we've got y, and we've got z. Now, like we said, we've also got this transversal here. And angle z and angle x, if we trace it out, kind of has that z shape to it. And that z shape is a dead giveaway for alternate interior angles, which means they are congruent. So angle x also has to be 32 degrees. And that was a lot today, guys. Main ideas were just that triangles add up to 180 and the remote exterior angle theorem. That if you have an exterior angle, you can add the two remote interior ones to find the measurement of the outside angle. And see you guys in class.